One of the keys to understanding a new or special field is getting to know something of its mood, a particular flavor that's often given by its jargon, its technical vocabulary, and its special words.
I have a card reader, CRT tube, a mag tape, or a mag disc, any of which can provide input data bits to our CPU.
Through a filter, into the differentiator, couple limiters, shapers, rectified, and hitting the line drivers which will drive the DC cable.
Data's in the control unit, everything is under control of the read-only storage, and then pumped into SURDs where the clock and data are separated, the clock being used by the serializer, deserializer to find out where the data is and whether it's zeros or ones.
Ships it over to the CPU via the channel interface along these internal ribbon wires and feeds the GR reg, gated by the channel across this set of cables right here, coming into storage where the output of a driver conditioned by SAR.
Each X and Y line that enters the storage array addresses a particular bit. And with the absence or presence of a pulse coming on the cable, the inhibit line controls the writing of this position so that it has a value of either 0 or 1.
And at the bit level, the value is determined by sensing the current flow resulting from the coincident excitation of the XY lines. This data, then, is located in an output buffer register. From there, we ship it out on the interface and print it either on a typewriter.
Those were specialists speaking to each other. Levels of technical meaning surround even simple words, giving both a feeling and a clarity to the subject. These words belong to the special world of the electronic digital computer.
An automatic machine that accepts instructions and information. Following the instructions, it performs operations on the information. And reports the results.
The devices themselves, the electronics and mechanics, are referred to as hardware. But the directions that make the hardware perform operations are known as software.
A computer's programs plus the procedure for their use.
When designing a program,
A set of instructions for performing computer operations.
a programmer usually makes a flowchart.
A graphic version of a program in which symbols are used to represent operations.
The flowchart form shows the essence of the computer's operation. That is, its ability to compare two values, then take the next step based on the result of the comparison. Repeating that operation over and over until the desired condition is met. At this scale, the flowchart of a program in any field would look much the same. Once worked out, it can be given a name and called for as part of a larger program, a subroutine.
A program called for as part of a larger program.
Of course, the larger program can be used in building still larger programs, and so on and so on. Much of the power of the computer lies in the fact that, in an instant, it can call on the accumulation of years of program structuring. But every bit of this information must be turned into the electrical pulses to which the machine responds. Much of the tedium of this process can be eased by use of the mnemonic.
An easily remembered code word that stands for one or more computer instructions.
A program can be written to translate the mnemonics into machine code. Greatly elaborated and formalized, this leads to the design of a computer language.
A collection of mnemonics that has been selected and organized to allow convenient expression of a certain kind of problem.
Actually, inside the computer, the parts that accept and act on these sophisticated symbols are remarkably simple and direct. They switch and store the pulses according to the rules of Boolean logic.
A symbolic way of stating a problem in terms of yes or no decisions.
These few kinds of elements can be connected together to form logic circuits that do arithmetic. The connections get to be complicated. It's a complexity that pays off because of the extraordinarily short time in which electronic elements can change their state. In the computer, the basic operations can be done within the order of a nanosecond.
1,000th of a millionth of a second.
Within the half second it takes this spilled coffee to reach the floor, a fairly large computer could debit 2,000 checks to 300 different bank accounts and examine the electrocardiograms of 100 patients and alert a physician to possible trouble, and score 150,000 answers on 3,000 examinations and evaluate the effectiveness of the questions, and figure the payroll for a company with 1,000 employees, or verify the position of 300 aircraft within an air traffic control area. In cases where a pattern of behavior can be defined, the computer, through simulation,
The use of a computer program as a model of a real situation.
acts out all the parts of a problem in detail, can introduce randomly selected values and events, and predicts the result of a particular series of decisions. Many strategies can be tried in a short time, and the most advantageous chosen. When a computer is used to do pattern recognition,
The automatic identification and classification of shapes, forms, or relationships.
the program sets out to recognize objects or events or significant factors by their characteristics.
To have a machine listen to a spoken phrase and recognize the words, or inspect a fingerprint and identify its owner, or scan satellite photographs and locate a possible hurricane, or read a photomicrograph and identify an abnormality, or examine a chessboard and from it determine a good next move, these are all examples of pattern recognition.
To define those characteristics so that the computer can classify them accurately, one needs an algorithm.
A fixed, step-by-step procedure designed to lead to the solution of a problem.
Almost any problem can be solved that can be adequately stated. It is the spirit of the exact recipe, the precisely defined procedure, that permeates the work of people in the world of problem structuring. That makes possible the world of the electronic digital computer.